But next we are going on to our speaker, Kuznetsov.
Good evening. Do you hear me?
Yes, we can hear you. Thank you.
Thank you. I would like to present a little about our dusty plasma instrument for the monitoring of the dust on near the surface of the moon. Instrument it is called PML instrument, and it is on board of Lunar 25 and Lunar 27 missions of the Russian space program. Lunar 25 mission is scheduled to be launched end of this year or start of next year. Lunar 27 would be several years later. Next slide, please. The PML instrument for Lunar 25 consists of 3 units. First one, the impact sensor unit on the left side. Its purpose is to measure the dust fluxes, separate dust particles, and they are to detect dust particles as a counter, and to detect their momentum, mechanical momentum, their speed, and their charge. On the right picture, you can see other 2 units. There are Langmuir probes. There are distant units on that placed on the surface of spacecraft. The mass of the whole instrument of the 3 units is 1 kilogram 70 grams. It has relatively low power consumption, up to 5 watts. The operational temperatures from -40 to +65 degrees. The operational regimes are supported with in non-stop mode. If there would be enough power on the spacecraft, then we are able to work on the morning and on the day, on the evening, on the night of the lunar day. The dust particle property that we can detect are for dust charges. It's from 1,500 elemental charges. For momentums, it's from 10 and -12 kilogram per meter per second, and this corresponds to the sorry. Can you turn back to previous slide? Thank you. And it corresponds with the dust particles with dimensions like 10 micrometers and speed 1 meter per second. The detectable velocity depends on the dust particle mass and starts from less than 1 meter per second. And for Langmuir probes, detectable plasma current changes are from 3 picoamperes to 100 microamperes, and with plasma potential with potential swipe from -88 to +88 volts for better resolution. And next slide, please. On board of the spacecraft, impact sensor locates on the special balcony. It's thermal stabilized, and the aperture of the instrument located out of the spacecraft with the angle 45 degrees to the surface. Langmuir probes located, the first one is on the balcony also, and the second one above the solar array. For now, the flight model is fully completed. It is mounted on the spacecraft and ready to flight. It's fully operational. We performed a lot of tests for this instrument. Sorry, can you please return to previous slide? Thank you. So we performed a lot of tests, including qualification tests, thermal vacuum tests, electromagnetic tests, and a lot of them, including calibration and functional testing. For calibration, we used the special vacuum chamber with injection, with the possibility of injection of charged dust particles. On the top picture on the center, you can see the schematic of the injector. It is several spheres, and we can put dust particles in between the spheres and apply high voltage up to 12 kilovolts. And then this dust particle started to jump between the spheres, charge, and inject to the vacuum chamber. It's necessary that these particles are conductive, and their sizes should be from 10 to 400 microns. And velocities on the bottom side of the vacuum chamber are from 2 to up to 100 meters per second. And charges of the particles are from 1000 elemental charges, but or most ordinary is 10,000 to 12,000 to 20,000 particles. So can you please next slide? The measurement, the scheme of our measurement technique is on the top picture. So on the bottom plate of the instrument, we have 24 piezoelectric sensors, PZT, lead zirconate titan, and above these PZT sensors, we have charge-sensitive grid. So from the charged particles, we can see the charge time when this particle passed through the grid. And we can see mechanical momentum from the piezoelectric sensor and the time when the particle hit this this sensor. So on the left bottom picture, it's from the proof of concept time when we test this scheme. Violet and green detectors are from the vacuum chamber. They shows the speed and charge of the particle, and blue and yellow signals are from the grid and from the piezoelectric sensor. On the right side, you can see the pictures from the flight model. The top one is from the piezoelectric sensor. It corresponds with particle 25 microns, the speed of 10 meters per second. And the bottom picture shows from the calibration experiment, from the calibration setup. The red and brown signal are the signals from the calibration setup inductive sensor. It shows us speed and charge of the particle, and the blue signal is from charge-sensitive grids. The green signal is from the piezoelectric sensor. So the next slide, please. Here's the result of our calibrations for the instrument. We have a range of velocities and charges for different particles and different voltages that applied to the injector. So we detected these particles and have a lot of statistics and try to work now with all of the statistics and make some papers. Next slide, please.
5 minutes.
Thank you. Next slide, please. And for longitudinal probes, we made an experiment with wolfram filament inside the vacuum chamber. We applied the current through this filament and made an electron current that we can detect with our longitudinal probes. Next slide, okay. Thank you. And we could detect the electron current at least 50 nanoamperes with a temperature of 37 electron volts and electron density of 60 million dust particles, sorry, 60 million electrons in cubic meter. So the surface of the electrode is coated with gold, and the surface is 5.73 square centimeters. Next slide, please. Next slide. Thank you. So one of the main problems of the Lunar 25 instrument composition is that we have longitudinal probes that located on board the spacecraft. So we will see not exactly the undisturbed lunar plasma, but the influence of the spacecraft on this plasma. Which can be great on the distance for 10-20 centimeters from the body of spacecraft. So we can work with it, but we have to respect this situation and analyze the data very carefully. And for the Lunar 27, we have an improved version of the instrument. This instrument is under development now, and we will use also the booms that will deploy and locate longitudinal probes, 3 longitudinal probes on the distance at least 1 meter from the body of spacecraft. It also allows us to locate charge sensitive and impact sensor near the surface of the moon, which can increase and give us a better statistic for the small particles that can reach these sensors. So next slide, please. Next final slide. So we are prepared recently a paper about this instrument that will be also in English. With there will be more details, and also I hope this mission will be successful and our experiment will be awesome. Thank you.
Okay, thank you.